Here are a few more examples in solving the question of, are these two drawings, enantiomers, diastereomers, constitutional isomers, identical or the same? Identical or different. So, looking at these, we have the same connectivity, 5 carbons across. We got substituents at carbons number 2 and 4. They're both OH groups. And on first glance, it looks like the stereocenters have been flipped in both cases. So we might automatically say enantiomers and move on with our lives. However, if we look at these molecules, they have a mirror plane of symmetry down the middle. These are very symmetrical molecules. And if you envision taking, let's say, the left molecule and just flipping it horizontally, that would turn both of those dashes into wedges, and it would give us the same molecule, the same drawing as this one. And so these are actually meso compounds, which means they're the same, or identical, or however you want to answer that. But these are the same. They are a set of meso compounds. Let's look at these two drawings and answer the same question. Again, we can establish that they're both 6-membered rings. They both have 3 substituents on them, and those 3 substituents are chlorine, OH, and methyl. So they are not different. They are going to be one of our different types of isomers. They have the same formula. Are they connected the same? Well, the wedges are in the same place, the dash is in the same place. However, I flipped, when I drew these, the chlorine and the OH are in different locations. And so we don't really need to think much more about this. These are constitutional isomers. And I will admit, this answer is less common than, say, enantiomers, diastereomers, or identical. However, we may encounter it at some point on a quiz or an exam. So these are constitutional isomers because the chlorine and the OH are in different spots on this 6-membered ring.